Okay, here's the question. A body of mass 2 kilograms moves under a force. The relationship between time and displacement is given by x equals t cubed over 3. What is the work done on the object in the first 2 seconds of motion? Okay, well, this is a work problem, and we know that work is equal to the integral of force with respect to distance. So we'll also add in our limits here from x1 to x2. And I don't mean distance, I mean displacement. So work is equal to the integral of force with respect to displacement. But since we're dealing in one dimension, distance and displacement are just about the same thing. Well, do we know the force and do we know the displacement? Well, not right away we don't. But if we look at what else we're given that the displacement of this object is a function of time, and specifically that function is x is equal to t cubed over 3. If we take the derivative of this function with respect to time, we get dx dt is equal to, we just do the power rule, and we get this is equal to t squared. And if we treat this derivative like a fraction, which you can actually do, you multiply through by dt, and you get dx is equal to t squared times dt. And we can substitute this expression into the integral. And so we are changing the variable of the integral by way of substitution, so that work becomes the integral of force times dx, which is actually equal to t squared times dt. Like so. And now, since we've changed the variable of the integral, we're also changing the limits of the integral into t1 and t2. We're sort of bypassing that step right now. But integrating with respect to x from x1 to x2 should be the same as integrating with respect to time from time 1 to time 2. Okay. And we know what time 1 and time 2 are. Time 1 is going to be equal to 0 seconds, and time 2 is going to be equal to 2 seconds. But we'll come back to that, because we figured out how to substitute out displacement, how to substitute out x. Well, what about F? We don't really know what F is yet, do we? Well, we know that F, force, is equal to mass times acceleration. When in doubt, remember that. We know that acceleration, well, let's look up here again, actually, at the derivative we took of displacement. Remember, the derivative of displacement is just speed, or velocity. Okay? And if we take the derivative of speed, velocity, that is acceleration. So acceleration is just the derivative of speed with respect to time, and that is going to be the derivative of t squared with respect to time, so that's just going to be equal to 2t. So that the force applied to this object is equal to the mass times the acceleration is going to equal mass times 2t, which is equal to 2mt. So let's plug that into the integral, so that work is equal to the integral from time 1 to time 2 of force, which is, we've calculated to be 2 times mass times time, times t squared dt. Well, now we've got an integral in terms of time, and just time, only time, which is great. So let's simplify this a little bit. So this is equal to, I'm going to factor out the 2 and the m. And so we're left with a t cubed in there. so that this is equal to the integral of t cubed is just 1/4 t to the fourth. And this is going to be evaluated from t1 to t2, or specifically from 0 to 2 seconds. And let's simplify this a little bit more. 2/4 is 1/2 times the mass times t4, t to the fourth, from 0 to 2. And remember, our mass is equal to, what, 2 kilograms? So we plug that in, 2 kilograms. And then we evaluate this t at t equals 2 and t equals 0. 0 to the fourth is just 0, so this is equal to 2 seconds to the fourth. And this gives us 2 to the fourth times 2 is 32 divided by 2. This is just equal to 16 joules. So let me know if you have any questions.